All right, hello everyone. Welcome back to another coding interview. Today I have a very special guest with me, Dan Abramov. Dan, would you like to give just a quick introduction for yourself for those of you that have no idea who is Dan?
Yeah, thank you for having me. Hi, I'm Dan, and I work on React. I did not create React, but I work on it on the React team, and I co-created Redux and a few other projects in JavaScript ecosystem. So, but today I'm gonna try to get hired by Ben.
Let's go.
So good luck to me.
Sweet. So the format of this interview is we're going to start with some like brain teasers slash discussions. It's not really a brain teaser, just to like warm you up, get you thinking. Then we're going to jump into kind of a web dev question, and then we're going to finish with an algo question and see how far we get. So my first question for you here is, all right, and actually we're not going to need that guy, is in JavaScript, okay? There is the let keyword and there's the const keyword. What do each one of
Sure.
these do? And when should I use let and when should I use const?
Okay. So the both keywords let you create the binding, or like a variable. Um, But the difference is that if you basically const prevents reassignment. So if you declare const something, then you can't later do something equals whatever. But if you use let, then you can do that. And note that that is not to be confused with immutability, because if you declare const something equals some object, and then you do like object dot whatever equals blah blah, that is still allowed by const. So const actually doesn't prevent that.
Like that?
Um, yeah, yeah, like that's fine. That doesn't break anything. And as for which one you should use, like my personal opinion is like whatever. Like I don't think it actually matters. Well, at least like if because if you use a const and try to reassign it, there'll be like an error, and then you can just fix it. But there's a lot of people who think that it's important to use const whenever you don't reassign. I don't care. Like whatever your opinion is in the project, I'll follow it.
And personally, if you're starting a new project, are you somebody who uses const or are you somebody that lets every single one?
I'm very chaotic. Like I would in one function, I would like always use let, and then like I kind of my mood changes, and then I always use const by default. So it's like totally.
Oh, you do a
Sorry,
mix.
is that
Okay.
like, are you gonna fire me now?
Personally, I actually am somebody that does const. I'm like, if I don't
Okay.
reassign it, I'll constant because it's like a microscopic check. But I also am the same boat. If everyone wants to use let, like I'll just use let. Like,
Yeah,
okay.
that's fair.
My second question for you is there's this lovely library that is often used with React. You may know of it. It's called Redux.
Heard
When
about it.
should I use it in my React project?
Well, if the team is already using it, that seems like a reasonable reason to keep using it. Uh, Other than that, I don't really know. Like, um, I think I think it's mostly a matter of convention. Like if you
Hmm.
work with people who already know it well, like, or if it's like in your requirements that it has to be implemented with Redux, I think it kind of makes sense. Um, if you like, I kind of think of Redux as the thing where you put something that you don't know where to put, and I think I would kind of look for better places to put things. Which I guess it doesn't answer your question, but I would like first, like maybe like Redux can be like the last option. If I don't know where to put something, then I put it there. But first I would explore, okay, like, is this some kind of like server data? Then like maybe it needs to live in some cache that is like purposefully designed for holding server data. Or like if it is some kind of UI, um, like if you imagine like two pieces of UI that use the same data, like you probably want to think about, do I want them to be in sync with each other? So like if I render the same component twice, do I want, for example, type in a comment in a post component and like there's the same post component for some reason on the same page. Do I want what I type to appear there? And like if you don't, which I think you usually don't, then it should be local state, even if it's kind of hoisted up. But in some cases, you do want that data to be shared, but then that usually has to do with like things that don't actually live on your computer, right? Like things that are on the network. And then I think for those, there's usually like better solutions. But if you don't know where to put anything, where to put a piece of data, and like you've run out of ideas, then I think like sure, like you can put it there.
Okay, so if you're starting a new project today, you would only use Redux if you had a piece of data where you could not figure out where to put it anywhere else. Like Redux is the last place you're putting it, it sounds like.
Yeah, and maybe I wouldn't even use it then. But yeah,
Okay, what are you using instead? What should I like? Are you designing your own cache? Is there another library you like better?
I think it depends on the use case, right?
Hmm.
Like what is the use case you're thinking of? Because like for something like server, like data coming from the server, which I think in a lot of cases that's what people want to use it for. Like I would use like a cache like I don't know, like React Query or like Relay or Apollo or whatever people use these days. And then for things that are kind of local, like I think usually that would just be a local state, maybe hosted at the top of the app. But I would think like it's some kind of local state.
And if it's hoisted at the top, do you like to use context for that?
Yeah, sure.
Okay. All right, I have one last small question for you. There's this dangerously set inner HTML thing. When
Okay.
should I use that in React? It's one of those things I can stick on one of my divs, my span tags, and I can use this. First off, what is it, and when should I use it? Should I ever use it?
Yeah. So it's basically an equivalent to the inner HTML DOM API, except inner HTML doesn't sound scary, but this one does. Um, the purpose is, well, in some cases, you just have some HTML, maybe like from your content management system, or just like something from your database that, I don't know, like maybe you had a like you just have a bunch of HTML in your like in your database, and you need to display it, and like you need to pump it into the page somehow. You can't like parse it all and so on like that. That would be inefficient, and you know that it is safe, right? So I think that is kind of the key thing. Is like the only like you basically want to make sure that all of that HTML is entirely safe. So it's like fully sanitized. So either you're the one producing it and you're sure that you're not like interpolating some user input, like I don't know, whatever like the user has typed without sanitization, or yeah, that's basically what it is. And then I think it actually kind of sucks, like in terms of like we would probably do it a bit differently now, because the way it currently works is this. So there's also like this super ugly property name in order to
Yeah.
um, so the thing is like I think actually it would maybe make more sense to do this um, because the thing it's kind of like a chain, right? It's the concept of like you want this thing to be basically you want to set up so for example I think at Meta we have this kind of a lint rule that whenever there's like a match for like I think dangerous is set in HTML or underscore HTML, somebody from security will be tagged on the PR for review. So
Oh, that's
that
cool.
is kind of the point, is like to prevent those holes from existing. But I think it would make sense to mark this thing as tainted because it could be coming from like that is where the potential vulnerability is introduced, right? So like if you have something like somewhere in another file, and that's where this thing gets created, and then there's like a bunch of abstractions in between, and then eventually like this kind
Mm,
of gets used like somewhere, like maybe I don't know through some other functions. Like that is the actual place where the potential
danger
kind of hole
actually is.
is.
Yeah.
Yeah, because like you need to verify that this part is from a trusted input rather than this part, but it is what it is.
And do you see like would you guys ever deprecate dangerously set HTML and add that new prop in? I guess this is outside the interview question, but I'm just curious.
I think like probably not. Like it's fine. It is what I mean. The functionality itself is like essential. Like it has to be there. Regarding the naming, like it could be better, but it's probably fine.
So it sounds like to me that whenever you're getting HTML from your server, you may want to use dangerously set HTML, and you would want to just
Well, you need to be sure that whatever you have on the server is actually safe, right?
right.
That is, yeah. So it's for very limited use cases where you're actually confident that it is safe. Otherwise, you can just make a mess.
All right, we're going to be moving on to the second question I have for you. This is more of a general web design question that's going to come up in pretty much any application you ever build. And I have this div here, and I would really like
Okay.
you to center it for me, both vertically and horizontally on this page. So it's like right smack in the middle there. Could you help me
Okay.
out with that?
Yeah, let me try that. I actually learned how to do it like literally a few months ago.
Sweet.
But
He's about to
let
bust
me
it
give
out.
the
This is the hardest question in
let,
web dev.
I'll give it a try. I'm not sure I'll do it right, but well, I think the first thing I want to do is just to make sure that it's actually well, no, wait. I have to make sure that the container what is this the con so I want to center it in the body, right? So let
Yes.
me just check what the Uh, let me just check where the body is. Okay, awesome.
Okay, let me get the
I'll,
style here. We'll do this side by side.
okay, so I think I need to, or do I need to give it to the parent? Maybe I need to give it to the parent. Uh, like something like, I need something like this, and maybe I need to give maybe display flags to the parent.
We're getting very close.
Wait, this doesn't work. Why doesn't this work? I thought this would work. Okay, let me, is there something in the console? No. Inspect this. Okay, so body is not actually okay. Well, but why does it have the okay? So are you saying that it's not actually 100% or okay, body is 100%? Oh, there's a root there. Okay, so let's maybe do this. Okay, so root is definitely not, and it's the body. Okay, this is really annoying, but let's do this. So the body is 100, the root is still, if I remove this, okay, that is a bit closer. So have the root and I have this thing. Maybe I need to give this, but wait, I think I have to give this to the parent actually, maybe. Is that how it works? This is really hard. Okay, let me try this. Come on. No, this didn't work. Why doesn't this work? Okay, so this is still not 100%.
Yeah, so I'll give you a hint. The root needs to get bigger. It needs to take over that entire screen. That's one way you can do it.
Yeah, yeah, that's what I'm trying to do. But I think the root is big, right? Like if I,
Well, the
oh no,
root's
it's
red,
not.
right? Yeah.
Why, well, I mean, I could just give it like this, but
There we
I
go.
mean, that's,
There we
yeah, but
go.
that's kind of, but I want to understand why. Like, wait, why doesn't 100% work?
I think it's
Because
because you have
like
to add it to the
body,
HTML tag, maybe.
oh shit, yeah,
Yeah.
maybe
I
that's
think
it.
there's just like one other guy up there.
Okay,
Yeah.
okay, I forgot. Yeah, yeah, that worked. Let me remove this. Wait,
Oh yeah,
okay,
sorry. I
you,
took it back. I took it back. Here you go. There
Okay,
you go.
okay,
Both body and
cool.
HTML are now with height 100%.
Yay.
Okay, sweet. And for
Awesome.
what you did there too to like kind of get around it, if you get rid of the HTML, so what Dan did is he used, instead of 100% for the height, he used view height, which gets you like the 100% or 100 view height pixels. I don't even know what they're called. I don't know what to call them pixels, but just takes
I
over
think
the
it's
whole screen.
view.
It's called view
Yeah,
height.
but the problem is like
It's
it seems
hacky.
bad
Yeah.
because yeah, it's like if you have multiple of those, that's not gonna work, right? So it's doesn't scale.
Yeah. That makes sense. Nice.
Yeah,
You've now centered a div. Congratulations.
took me a while. Yeah.
All right. All right, Dan. Our last algorithm question I have for you is a classic. You work at Facebook, and now I'm curious to see if you have the skills to work at Google. There's a famous question
Okay.
they like to ask of whether you can invert a binary tree or not. So what I want you to do is write a function here, fill it out for me, called
Okay.
invert tree. You get a tree as a parameter, and I'm going to send you an image of what it looks like to invert a tree. Basically, I want you to take every node, the left and the right node, and swap them. And it should happen at every single level. So I want you to
Is
pretend.
it
Yeah, go ahead.
is it okay to mutate it, or do you want me
Yes.
to like copy
Ideally,
it?
you do it in place mutation. So to give you an idea of
Okay.
what this tree looks like, the
Okay.
tree looks like it has a left object and a right object, which then has a nested left object, right? But it's going to have like what? Let me make sure I'm doing this correctly. It should actually really be called node, not to confuse you. And
Okay.
each node has a value, like
Okay.
5, and then a left branch and a right branch. And there's a whole
Mm-hmm.
nother tree in the left and a whole nother tree in the right, possibly. Or left and right could be
Mm-hmm.
null.
Okay.
Does that make sense?
Yeah, I think should I start?
Yeah, go ahead.
Okay, let me just put this picture side by side so I can see. Uh, so I was actually always scared of this like binary tree thing, but it sounds simpler than I thought it is. But I'm like underthinking it or something. But I imagine I should be able to just so we take the left thing, so that would be node that left, and to we want to point the actually let me just read them both just in case, and I'll think about it later. So I want to point the right thing to the left one, and I want to point the left thing to the right one. And then I think I want to recurse. So I want to do this and maybe this. So I haven't actually thought about it yet, but does that seem like I'm on the right track?
Yeah, you're actually just right. That's
Okay.
actually just how you
Okay.
invert a binary tree. You just blitzed through that. I'm pretty sure you took like 2 minutes, 1 minute. I used to hold the world record of the fastest inversion of binary trees on YouTube, but I'm pretty sure you just broke my record right there. All
Yeah, I'm
right.
not super well thinking about it. Like I'm not super
Mm-hmm.
familiar with like dealing with trees in a computer science way, but like in React,
Everything's a
that's
tree,
literally like
right?
yeah, like that's
Yeah.
the thing you do all the time. Like you just recurse into the thing.
Now, I guess
But yeah,
follow-up question for you. Do you need these intermediate variables?
probably I would expect that it should be possible to do with just one, right? Because like I can save the left one. So if I save the left one, I have it, and then I reassign the left to the right. Well, I'm not sure. So if I save just let me kind of save this and just sketch it out here. So if I save just the left one, right? So like, let's imagine I have left A, I know it's not supposed to be, but it's just easier this way. So this will be A. So what I want to produce is like left B, right A. So take left into now I can reassign now that left because it has been saved, so I can do this. So now both of them will be, we'll get like node that left and node that right. They're both A. And now I do node that right equals left. And I think that would give me the same result. So I should be able to do it like this.
Yeah, I think that works too. And then you just have to like change
Oh, wait.
this.
Yeah. Yeah.
And left.
I guess that's kind of ugly. I'll do this.
Yep. Exactly right. Okay, then you're ready for my bonus question. I didn't think we were going to get to my bonus question, but you're doing fantastic so far. Let me pull up my bonus question for you. Bonus. All right, this is my bonus question for you. So there's 100 holes in a line, and you can think of the holes as just like, you know, something like this. And this hole is index 0. This one's index 1, and so on all the way up to 99, right?
Okay. Okay.
And there's a rabbit, and it's hiding in one of these holes. Okay?
Okay.
And you can only look at one hole at a time. Like you can guess, I bet the rabbit is in hole index 1, or I think the rabbit is in index 50. All right?
Mm-hmm.
But every time you guess, like let's say I guess that rabbit's in hole 1. Every time I do that and you guess incorrectly, the rabbit jumps to an adjacent hole. All right?
Okay.
So an example of that is if the rabbit was in this hole here. Let's say this is 0, 1, 2, 3. And you guessed 2, which is not right because the rabbit's not there. The rabbit can either jump to 0 or 2. So
does the rabbit always jump?
The rabbit always jumps. Oops. Or he.
Okay, and the rabbit, does the rabbit ever jump to the one? So if I look at if the rabbit is at 2 and I look at 1, can the rabbit jump at 2, or does the rabbit always jump away from?
No, it doesn't always jump away. You could oscillate back and forth. You could guess 1, it goes to 2. Or like you could go back, it can jump back and forth between the same 2 holes. You go back and forth.
Okay.
Right? Like let's say you guess 1 and he's not there. And then he hops to 1 and you guess 0, but he's not there anymore. And then you guess 1 and you can go back and forth. So it can oscillate like that. The bunny can just whoop, 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 whoop.
Yeah, the specific thing I want to ask is so if the rabbit is at 0 and I guess so this is what I guess it's 1, but it's not 1.
Right.
Can the rabbit do this in the next turn? Can the rabbit jump at 1? Okay, cool.
Yep. And so your job is to tell me how you would find the rabbit. Like what sequence of guesses would you do to find the rabbit? And then if you can tell me the big O of it when you're done with it, we don't.
Yeah, let's just get to something
that.
Yeah. Okay, this is really tricky. I guess there's probably some simple solution, but I need to think a little bit.
Yeah.
Okay, so every time I look at a hole, the rabbit jumps. A good solution finds the right algorithm, blah, 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 blah. This is interesting. I can't even if I just go over like each hole,
right,
I think I can still miss it, right? Because it's not, I could easily miss it.
Right, if you just guess 0, 1, 2, 3, 4, 5, all the way up to 99, it could just hop.
Yeah, that is pretty annoying. Okay, let me, I'm probably not gonna pass this one, but let me just first I don't like thinking about hundreds. That's It's really annoying. I'll think about like 3. So let's say how would I like do this as a human? So if like, let's say the rabbit is here and let's say I could make 3 possible guesses, right? I could like guess here and be okay. I could guess here and be not okay. Could guess here and not be not okay. And then after this, the rabbit could jump. The rabbit. Well, if I'm here, so the program finishes when I find the rabbit, right? That's
Right.
determination. So like in this case, I didn't find the rabbit, and then the rabbit has only one option because the rabbit is at the edge. So the rabbit would have to jump. Would have to jump here, I guess. So as a human, I could. It's pointless to check this again because I know that. So what do I know? I know that the rabbit can stay at one hole. So rabbit has to move.
Right.
So if I check like n, I'm sure they're not. Is rabbit gender neutral? They're not at n. So it only makes sense to check n minus 1 and plus 1. But I also know that if they were at some like some m, they can only be at m plus 1 or m minus 1 or at the edge. What are those edges?
And just to clarify, when you say this, right, you mean like if the bunny's at 3, after that it can only be at place 2 and 4. Is that right?
Yeah.
Okay.
Yeah. I don't see an obvious way to do it.
So 1.
Okay, is it okay if I take some time to think?
Yes,
Because
please
like
do so. And I can either give you like a small hint if you want, or if you want to take some time to like crunch in your head, like either one.
yeah, give me a bit of time just to think about it, but then like maybe like in 5 minutes, if I
Yeah.
have no success at all, then you give me a hint. Okay, I'll keep thinking about this scenario. So say the rabbit is here and I chose the wrong place. So the rabbit jumps. Then yeah, the rabbit can oscillate. So for example, if I just keep checking like the same spot, I would miss the rabbit because like the rabbit could be somewhere else and just stay in that area.
Right.
So I kind of have to keep checking different places, but it's also knowing that there is kind of no kind of memory in the system because the only thing that seems of consequence is like the last action. So there's like nothing that permanent, like it's
You're
not
not
like
making
if I checked it,
progress. Right.
yeah, I'm not making progress. Yeah, like if I checked somewhere, like that doesn't mean anything. So it seems like whatever the solution is, it has to take advantage of, well, I guess like I guess like the first question is like, is there even a way to solve it like deterministically? Actually, like, is it guaranteed that I'll find the rabbit? Like, I'm not sure if it is.
See, when I first saw this question, I thought the same thing. I was like, it's actually impossible to find the rabbit. It's a trick question. But it turns out there's actually a way that you can deterministically always find the rabbit.
It kind of feels, what sorry, one thing that this reminds me of, and I may be like completely kind of off like not going in the right direction. But it reminds me of, like in chess, if you if you have two rooks, you can kind of squeeze the king by
Yes.
moving them like step by step kind of to the edge, and then the king can't escape. And I feel like maybe if I do some kind of movement where I check like the next one and then fall back to previous one, check the next one, fall back to previous one, and kind of step like this, I won't give the, well, but yeah, is that somewhere in the right direction?
Ish. I'm gonna give you a thing to think about that helped me like start thinking in the right direction with it. And that's just
Okay.
like, let's assume the rabbit is at position 50.
Yeah.
Think about where the rabbit is gonna be at t plus 1, and then where
Yeah.
it's gonna be at t plus 2, and so on, of like where the possible places it could be.
Yeah. I mean, if we start, like at 50, then t plus 1 is either 49 or 51. Then t plus 2 is either 48, 48 or 50 or 52, and so on. Like it just keeps kind of like depending on if they move like left or right, the possibilities.
Exactly.
Well, like one thing that is certain is that it's gonna stay like if like even odd, I guess. That is kind of predictable, right? So it's like it's t plus 1, all of these are gonna be odd. I don't know if that helps.
Yep. No,
T
the
plus
the
2,
key to
all of
this
these
is the
are,
odd even oscillation.
yeah. So how does that help though? I almost feel like it would be easier to solve if I kind of knew where the rabbit started or something, but because I don't have this information, I have to first encounter the rabbit by chance, don't I?
Well, let's assume the rabbit starts on an even index. How would you find the rabbit?
Right.
If you knew that
Uh,
information. Like it was either
see,
0, 2, 4, 6.
yeah. Well, I would know that. I don't know if that. What does this even give me? Like, I would know that if, like, on each step, again, like the rabbit would change to the odd position, and then on each next step, it would change back. But I don't see how that helps me uh, to know which kind of area to look at. Well, okay. One thing that's interesting that I know is that the rabbit can't jump further, right? So they kind of have to, like, if I kind of keep chasing the rabbit has to cross me. Well, yeah, I think the rabbit kind of has to. I just need to make sure that as I walk, I somehow step on the places that the rabbit that I kind of squeeze the rabbit in a way that the place they would want to jump to would be the next place that I would check. So either they jump to the place I'm going to check next, or they jump away, but then eventually I squeeze them to the edge, and then they have to do it. So I think that would be a possible solution, is like to keep walking somehow, like because I know if it's like even or odd, I know that I can place myself. So for example, if the rabbit um, is at 1, for example, I check 0. And so if they jump left, I would find them. If they jump right, so they're on 2. And later I check and I check 1 next, because if they're at 1, I find them. But if they're on 3, I wait. But that isn't that just like checking each number one by one?
It's close to that, yeah. So like in this case, let's like this is extra information, right? It's not always going to be like this, but this is a slightly easier problem to solve. The slightly easier problem is you would know that the rabbit is on even index. So in this case, how would you corner the rabbit and find the rabbit? And you're guaranteed that every other, so like here's like the extra bit, right? You know every other guess the rabbit is on an even index because it has to go even odd, even odd, even odd, even odd, right?
Yeah. Yeah, so I guess I would, if I know that the rabbit starts at 0, then I would check 1 first. So if I check 1, well, when I check, is it that would be like the next step, right? So the rabbit is originally, for example, at 0. So I check 1. In that case, I catch the rabbit. Like there's no other way. But like if the rabbit is like at 2,
Right.
right? I still check 1. The If the rabbit jumped at 1, then they're caught. If the rabbit jumped at 3, then my guess is wrong. But the next thing that I do is I check like 2. I think it's just kind of, well, I think maybe it's easier for me if I actually write. If I had like a test case, I could play with it, but it's annoying to do it in my head.
Right. Does it help that for you to type it out? I also suggest try it with size 4. And the reason why I'm suggesting size 4 is 4 is an even number, and so is 100. And that lines up nicely.
Are we gonna run out of time if I just like write a small test harness?
I say like take as much time as you want to take.
Like it's just really annoying to think in my head.
Yeah, go
Okay.
ahead.
I don't know if this is gonna go anywhere, but I don't like to think about things like this purely in my head. So let's say we have okay, so let's say we have okay. This, and we have well, actually it's easier to just say, so let's say we have, let's say the rabbit starts at 0, and let's say that, yeah, that's fine. So the step function is there are basically the I'll just write it with random. I don't know if that's weird. So if I have this thing, and let's just kind of play with it. Is there like a console here?
Yeah, you can.
I'll just erase the rest. It's annoying me. So where is the console?
It should be on the right side.
Okay, console. Yeah, awesome. There is a console here. Okay, so the rabbit. Let's say Okay, that seems legit. It seems like something a rabbit would do. And then I don't know if this is going to be helpful at all. So the thing I want to write is so I don't know the rabbit's position. I can only guess really, right? So um, so if well, so what I want to write is really a step by step. What I want to keep doing is the rabbit steps, and then well, this is overly complicated. So I want to have some way to figure out. This is how I'm gonna attempt to. So if I guessed right, then I will break out and I will say the rabbit, and otherwise I keep doing it. And so if I just start with like just using the okay, let's run it. What? Wait, what? For example. Oh, and I should also do rabbit jump to well from okay. So now I can kind of see what's going on here. And then here I'll say okay, so this doesn't work. So just which is actually interesting. So yeah, because yeah, this doesn't make sense because there's only there's only len elements, right? So if I do it like this, so this is the naive approach where I just go through them like one by one. And so I think this is saying that the naive approach doesn't work because if so the rabbit started at 2, so third position. So the rabbit jumped from 2 to 1, whereas I should probably log what I'm checking. So I gonna check this thing. So okay, let's try again. So and I should probably
And just
also
so you
write.
know, not so you don't confuse yourself, tough
Yeah.
luck is shown every time.
Oh yeah, right. That is a good point. So I need to show it if I guess if temp is not well. That's okay. So let's try again. Yeah, okay. So the rabbit started at 2. So the rabbit jumped from 2 to 3, and I'm checking 0. Then the rabbit, wait, it can jump from 3 to 3. This doesn't make sense. So this should really be if position is, if we're at the end, we can only go back. If we're at the beginning, we can only go forward. Wait, this should be pause. But if the case is dependent on the random variable, we go forward or back, and we shouldn't need this content anymore. Okay, let's try again. So the rabbit started at 2. the rabbit jumped from. Okay, the rabbit. Well, do I check first? Does the rabbit jump, or is it the same
So
thing?
you check. If
I
the
check
rabbit's
first.
there, you win. But if you
Yeah, so this
miss,
step happens
yep.
afterwards. So the step happens here, I think.
Yep.
Okay, let me try this again. So
Okay, so you're trying to
okay,
write code to just see if the naive algorithm works.
yeah, I want to see, because so far it kind of works, but let me just bump this to like 30 and see. And let me start maybe at 10. So far it kind of feels like it always finds the rabbit. I know this is not a super scientific method of doing it. But I'm just trying to kind of gain the intuition for what is the case that like that doesn't work with the naive approach, if there is a case that doesn't work with the naive approach. Let me go back. You were saying like 4 is interesting. Okay, so let me, so if I start at 0, I don't, that's easy. If the rabbit is initially at 1, then I check 0, the rabbit can jump. So I think if the rabbit jumps back to 0, my approach is not going to work. So this actually, okay, I got a case that doesn't work. So the rabbit starts at 1, I'm checking 0. The rabbit jumps to 2, I check 1. The rabbit jumps to 3, I check 2. And then the rabbit kind of misses me because the rabbit jumps over back to 2 and I stop iteration. So that doesn't work. But if I check the same, what if I check the same place twice? I wonder if that would work better.
Also, did you have a meeting at 6, or are you good to keep going, just time wise?
No,
Okay.
I'm good to keep going. Yeah, but I don't know if I'm going in like a completely
We're a little
different
bit
way
going
than
down a hole that I'm not
kind
sure
of.
that's gonna help you. I can try giving you a few more things to try and intuit it. The thing I'll say
Yeah.
is I think the thing that's gonna lead you
Okay.
down to like figuring out the best is imagine you have 4 squares and then try the naive approach of that and see what happens when rabbit is on even index versus odd index. And what you'll find is the naive approach works for one of those indexes, but not the other.
Yeah, because if I start with, well, I guess like if I start with the, like basically if the thing that I start with is kind of synced up with the thing where the rabbit starts, maybe it will work, but then if it doesn't work the other way around, or okay, so let's say that I start 3, so rabbit starts at 1, and I start, well, no, let's say that rabbit starts at 2. So there are two even numbers in this example, right? Like if rabbit starts at 0 and I check at 0, it's kind of game over.
Right.
But if the rabbit starts at 2, I check 0, the rabbit is not there. The rabbit can go to 1 or 3. So if the rabbit goes to 1, and I check 1, that also catches the rabbit. If the rabbit goes to 3, I check 1. I haven't caught the rabbit, but the rabbit can go to can go to 2 or 4.
Well, notice 4 doesn't exist in this
So
example.
oh, there is no 4. So the rabbit, yeah. So yeah, it seems like if I start at the same like evenness, So if I started at 0, then I think I'm gonna catch any like even rabbit in the
Right.
naive approach. And if I start at 1, I think I'll find every odd rabbit
Yes,
with
that's
the
right.
naive approach.
So just
Yeah,
to
and so the
sum that up,
reason,
so you
yeah,
start counting at even, you find even rabbit. And the same thing works for odd.
yeah, and so basically like well, it seems like um, hmm, like I think you need to do it, but I don't know if it's the most efficient way. It's kind of the most inefficient way. Uh, so what do we mean so far? But what do we know so far? But it seems like we can do a full pass, or like starting with even, and then if we haven't had luck, we just switch to odd and do a full pass
Yep.
with the odd numbers, and then by then we're kind of guaranteed to find it. But I don't know if it's the best solution, but at least this should be, uh, this should actually give us the
Yep.
rabbit.
No, that's right. That's how you do it. And that's why like the even odd like oscillation is the key to finding this, is that you have to realize the way you're actually cornering the rabbit is by figuring out if the rabbit started on an odd or even index. And that's like how you're
Mhm.
gaining progress, if you will. But it's kind of weird because you only gain progress when you do a single pass. And then you know for sure
Yeah.
it didn't
Oh,
start on
that's
an even
interesting.
index, right?
Yeah.
So
And
you,
is that the best way? Like there's no better
no,
way?
this is the best way. At least this is as far as I know. This is the
Oh,
best,
okay.
like best slash only way to do it. Because again, the rabbit can just like hop back and forth, which is why you have to do the pass like you have to do it, right?
Okay, yeah, that is pretty interesting. I want to try it. Is it okay if I like try it in code
Yeah, yeah, sure.
to actually like verify that it works?
Yeah.
So let's say, okay, so the way we do this is we do two passes, right? So I'm gonna write two for loops, and then one of them starts with um, 0, and then starts with 1, and that seems like the only change I need to make. Is that so basically? Okay, so let's try to say like I have like actually 100 items, and it starts like somewhere in the middle. Uh, wait, why didn't uh, something is wrong with my code? I think because it doesn't. Oh wait, this is wrong. So if not found, then I want to keep searching, because like if found, it's just kind of an early exit. Okay, yeah, that seems like it works. I mean, it's not a guarantee, but yeah, that's pretty cool. It's an interesting thing, but I hate this kind of puzzles. Like
Yeah, I do too,
it
actually.
doesn't look like anything I would actually need to do at my job.
No, this is definitely the type of question that you're not expecting them to get correctly. You just like probe their brain to see how they respond to it. Because the one thing I do appreciate about this particular question out of like some of the other ones is you didn't need to know like Dijkstra's algorithm off the top of your head. So you can kind of like, yes, you have to like do these weird puzzle things in your head, but theoretically you should be able to
Yeah,
like get to a
yeah,
solution of
totally.
some sort without like just like not knowing the algorithm. Although some people would tell you you could just intuit Dijkstra's algorithm too. Um,
I don't even know what that is
it's shortest path of graph. Don't worry
anyways.
about it. Yeah. It's whatever. Weighted graph
Okay,
anyway. But
okay,
yeah, I think you did
okay.
very good. Like, and it was interesting to see you like want to write code to actually check if it was right. Um, which was like if I was doing this in a real project, I'd do the exact thing, right? Like you just write the code to check yourself. It was cool to see. And this is also my hardest question. Like when you just blitzed through the entire interview, I was like, all right, we gotta step it up a notch for Dan. Like we gotta
Yeah,
give him
no,
the
no,
bunny problem.
Yeah, that was good. That was good.
How'd you like
Liked
the
it.
interview? Which question did you like and hate the most?
Well, I think this one, like both liked and hated because I think it was like is I see what you appreciate about it. Like I definitely like that it challenges you and also like it is just common sense. So it's not like you don't need to know any fancy terms to do it. But it is incredibly frustrating, I think,
Right.
in part because I think just like psychologically, it feels like you're not making progress if because like usually when you think of like um, going through some sort of data and like finding something that like there's usually some measure of progress that you know that if you've covered something you don't need to visit it again,
Right.
and like this one kind of defies that intuition. So it was really frustrating in that sense. um, but yeah, it was also kind of fun. But um, I liked how easy it was to invert the binary tree because that
Yeah.
always sounded scary and it turned out that it's like a piece of cake.
No, I thought the same thing when I tried it. And also too, the binary tree and the bunny one are definitely questions where like you probably haven't even need to use that your entire software engineering career. Like has the bunny come up
Yeah,
for you? Probably not.
yeah, yeah. I'm trying to think of some problem that is similar, but it kind of sounds like if you have to do something, like if you have to search for something that kind of escapes from you, like something is terribly inefficient. Like why is it
Yeah.
designed this
You
way?
should just watch the bunny jump out of the hole and then you know where it went.
Yeah.
Like that's what I'm saying.
Yeah. Yeah.
Cool. Well, I would hire you based on this. One, you just went through the beginning very quickly. I liked your thought process when you were talking about let versus const, when you use Redux, and the dangerously set HTML. You're able to center a div, hardest problem web design. So you're going to be hired for that. Google would hire you because you're able to invert a binary tree. And you even got to the bunny question. We had to give you a few hints, but the bunny question is honestly really hard and you are like thinking about the right way to approach it where you're trying to make some type of progress that's the key like thing to realize is like I have to somehow make progress to find the bunny, but at the same time it's not obvious how you make progress, which is the hardest part about this particular problem which you respond with. So congratulations, Dan. I would hire you. You can start next week at Benawad Academy. I look forward to having you.
I have a few more. I have a few more interviews lined up, so we'll see. We'll see how
Oh,
it
okay.
compares.
Okay. We'll double the pay. All
But
right,
yeah,
cool.
it was really fun. Thanks for doing it.
Yeah, thanks for joining.